Yes. Can you help with that? It means like try to find the right value. So which one do you want me to take a look at? The first one?
Yeah, the first one.
Is the first one 1 over, what's the function?
It's x plus 1 over x.
X plus 1 over x. So number 1, conjugate function x plus 1 over x. Now, you guys know how to differentiate this because I have to remember. Yesterday, I just taught power rule to your class.
Yes.
And you're taking your test, is that right? Okay.
I'll take the first two, that's fine now.
There's a folder right here. Okay, there's a folder right here. It has a blank on it. Okay. All right, so you guys have had all kinds of derivative rules, all that kind of good stuff. It is totally up to you as to how you want to differentiate this. Here's what I mean by that. You guys could use quotient rule, or you could split it up into 2 parts. It's like this, like you could, and I'll just kind of ask which way you guys want me to do that. You could do this. You call the function 1 plus 1 over x, and do the derivative of it that way. You guys first have to tell me. So either way we do it, we're going to have to take the derivative, find whatever the formula is for the derivative, and then set it equal to whatever the slope is between the 2 points. Now, I'm assuming that on the problems that you guys are working on, the 2 points were given, like the x values, was there given an interval?
Yeah.
Over which? From 5, from where?
0.5.
From 0.5 to 2, okay. So what that would mean is, we've got one ordered pair that's 0.5 something, and then another ordered pair that's 2 something. So if we were to actually try to find, first of all, what we're going to need to set these equal to, we need to find the y values, like just regular old y values. So if I plug in a half, it's going to be 1/2 plus 1 over a half, which gives us 3/2 over a half, which means 3/2 times 2 over 1, which is 3. So that's what I get my ordered pair for the first x value. Then for the second x value, it's 2 plus 1 over 2. It's looking like we get 3/2. Which you guys can either put as 3/2 or you can put it in as the decimal form. It doesn't matter to me. So one of the first things you're going to need to do is actually fill out the 2 full ordered pairs. Because remember guys, that's an interval. That's a chunk on your x-axis. Okay? Now, before we do anything else, we should discuss this. Before we almost did this without thinking. If we were to sketch this function, you guys remember there's some conditions that need to be met before you even go any further. The conditions that need to be met are that between these 2 x's, your graph has to be continuous. And it has to have a derivative that exists all the way through. Now, if we sketch this, would you guys agree that if I type in 0, the y-axis is not going to work because x equals 0 is going to be a vertical asymptote? Do you agree with that? It's definitely going to be the case. And actually, if you want to, you could look at it like this. If I were to draw this and think about what kind of horizontal asymptote this would have, it would be y equals 1, because as x goes to infinity, your graph is just going to be y equals 1. So I think this graph is going to do something to the effect of this. It's going to have points up there, and then down here where it's, let's see, when x is like -1, then this will be, yeah, 1 plus -1 will be 0. Oops, no, that can't happen. -1, there it is. Okay, I know the graph is going to do something like this. All I want to first do is agree with you guys that at 0.5 and at 2, are these 2 points on part of the graph that's continuous and the derivative exists between them. Now, if we had started from -0.5 to 2, we'd be like, stop right now. Don't have to do the problem. Okay, so I think the sketch is good to be able to determine if our first condition is satisfied. So then I'm going to find my points, and then I need to find the slope between them. Would you guys expect your slope to be positive or negative? I'm just kind of curious, because then you can kind of know if you're way, way off. Would you expect the slope to be positive or negative? Negative? Okay, so if we want to try to find the slope between them, I'm going to use m for the slope of the secant line. We need to take the y values, so maybe 3 minus 1.5. If I do the top, 3 minus 1.5, and then 0.5 minus 2, 5. So I get 1.5 over, I think, negative 1.5. So I think I come up with -1. You guys check my arithmetic, but I think I get -1. And it doesn't matter which order you guys do your y values. It could be 1.5 minus 3, and then in this case you would do 2 minus 0.5. And you would still get -1.5 and a 1.5, and you guys would still get -1, right? Doesn't matter which way you do your slope. How are we doing there? So let me go back to this. What we're going to need to do then is set our slope equal to -1, but first need to find the derivative. So you guys have to tell me, we're gonna go back and do a little calculus, which way you wanna do the derivative. Do you wanna use quotient rule, or do you wanna just do the derivative of that little sucker over there? Call it a day. Do the derivative of this thing? Okay, let's do one more thing for this. It's been a while since we've done derivatives. Whoa, I was trying to put a plus sign and that didn't work. Okay, so if we wanna take the derivative of this, remember the derivative rules. The derivative rules are, we have to write that as x to the, excuse me, it might just help if I wrote that as x to the negative 1/2. Because every time I do a derivative, it has to have x in the numerator, so I like to do it that way. So the derivative for this function, what's the derivative of 1? 0, that's exactly right. And then the derivative of x to the negative 1/2 would be negative 1/2, and then x to the negative 3. Because I would decrease the exponent by 1. Remember these little quick memory tools. For derivatives, you decrease your exponent by 1, dE. For antiderivatives, you add 1 for your exponent. Now you guys have done both. You can see why I use the word decrease for derivative and add for antiderivative. It's kind of easy to remember that. So we're going to take our formula for the derivative, which was negative 1/2 x to the negative 3/2, and try to solve this. So now we just need to do a little bit of algebra to solve this. In fact, on this board, I used to put the purple marker a lot just because it's really bold and beautiful. I'm just using it. It sounds like a soap opera. Isn't there a soap opera for Bold and Beautiful or something like that? It's a dumb name for a soap opera. Like, they're not conceited about themselves. Yes, like, it's just weird. Anyways, okay, how would we solve this? How would you guys get x to the negative 3/2 by itself? What would you do to both sides? How about we ditch this thing? What are you going to do to ditch that? How about we multiply by negative 2? Would you guys agree if I multiply by negative 2, that's going to ditch that? You can tell me if you think I'm right or not. So then I get 2 over here on the right side. How am I doing? Now there are a few different ways I can solve this algebraically. It kind of depends on which way you'd rather go about it. But one way that always will work is to have your equation like this and think in terms of, hey, remember when we take terms with exponents and raise them to an exponent, what's the operation that you do with your exponents? You multiply your exponents. So if I need to multiply my exponent, and I'm going to solve this, and I want to get down to just x equals whatever my number is, then I need to raise this to its reciprocal. Because if I multiply negative 3/2 times negative 2/3, will I get 1? So that means that I need to take this and raise it to the negative 2/3, which means we have to figure out what the heck that means. But do you see what my strategy is here? Raising both sides to the negative 2/3. So I'm using whatever exponent is going to multiply together here to get x to the first. Now, what does 2 to the negative 2/3 mean? Well, first of all, if it's 2 to the negative 2/3, it means 1 over 2 to the 2/3. The negative means move it to the bottom of the fraction, right? Or you guys, at this point, you guys can type it into your calculators. But if I had to write my answer in like root form and clean it up, what kind of root does 2/3 mean? It means that it's the cube root of 2 squared, or if you guys would prefer to put it as 1 over the cube root of 4, that would work as well. But here's what I want you to do if you have a calculator nearby. And this, I'll do it myself since I've got one nearby. So 2 raised to the, in parentheses, negative 2/3. All I want to do here is make sure that it's in between 0.5 and 2. So when I get an answer here, guys, I'm going to go ahead and do an approximation. I get 0.62996 or whatever. So is that in between 0.5 and 2? I just want to double check that my answer is between them. Because if it's not, I know I messed up somewhere. Because the C that we're looking for has to be in between those two beginning and ending points. Has to always be between those. Now, remember, the theorem guarantees you might get more than one. You have to get at least 1 point. So it turns out that this one, I don't know if my picture's really to scale. It actually should be like way closer to that 0.5 than it is over to 2. But anyways, so that's kind of the bulk of number 1 on the note sheet. So if you guys would like to take a look at number 2 or 3, those are probably a little harder than the ones from the book. Because the book ones were just look at the picture and see if it satisfies the conditions. The ones on the note sheet were like actually find the C value that makes it happen. I will tell you guys on the AP test, more often than not, these types of questions that refer to this mean value theorem don't ask you to find C, they just ask you to guarantee that there is a C. So you go through the conditions. The conditions are, it has to be continuous throughout the whole entire interval, including the endpoints, and it has to be differentiable, meaning the derivative must exist between everything except the endpoints. And then there has to be a C in between A and B that this works. Would you like to either look at 2 and 3, or are we going to the book stuff? 2?
Yeah.
Okay, can you tell me what 2 is?
The equation,
Yeah.
g of x is equal to x to the third minus x to the third minus 5x minus 2.
Okay, and then what's the interval on which?
Negative 1.
Negative 1 to 3. Now, let's see how good your memories are, ladies and gentlemen. I know that my honors calculus students in here, perfect, yeah, put it right in the folder, then I'll make them all. You're trying to make me lose it, let's see how you are. I'm just teasing. Okay, I know my honors calculus students can answer this, since there's 3 of them in here. What kind of function is this? See, you were like, I'm not gonna be put on the hot seat. Notice it's just a bunch of terms that are added together. Help, look at that. He took the job away from you guys, you don't even have to answer. It's a polynomial function. The reason I say that is this. If it's a polynomial function, what is it always considered as you draw it?
Continuous.
Continuous. So if it's continuous and it's a polynomial function, they're like little kitty roller coasters. That means the derivative is always going to exist between the endpoints. The endpoints, whatever they are. Negative 1 to 3, whatever the heck it is. So again, we could do this in whatever order you want, but I just want to know this is continuous, the derivative exists. So I need to find what are the 2 y values. Remember, what you guys were being given here are x's on the x-axis. We have to find the y values, so we either do plug and chug using the calculator, or we do it ourselves. We can do it ourselves. I have complete faith in us, even though these are going to be a little bit yucky. So if we plug in negative 1, don't forget parentheses, it would be negative 1 cubed minus negative 1 squared minus 5 times negative 1 minus 3. I get negative 1 out of that, that becomes positive 1, I get negative 1 out of that. That's something like positive 5, that's something like negative 3. I'm thinking we get negative, I'm thinking 0. So I came up with 0. Please don't think 0 is a number that you can't get. You might just think the y value happens to be 0. And then we also have to plug in 3. So 3 cubed minus 3 squared minus 5 times 3 minus 3. So 3 cubed is 27 minus 9 minus 15 minus 3. Boy, doesn't this look like fun? That's 18 minus 15, that's 3 minus 3 equals 0. What? Okay, remember the 2 y values can be the same. That does not mean that it's a flat line in between. I know it's not a flat line because look at your function. It's got x to the third, x to the second, x to the first. It's a wavy function. It goes up and down. It just happens to be that if I were to draw this graph, that it just happens that at negative 1, 0, and at 3, 0, they both happen to be the same thing. So when we get to the slope, once we find the derivative for this little problem, we're going to be setting the derivative equal to 0 and then trying to solve it. That's going to be our next kind of big step. But we do need to do some calculus here. And the calculus would be, we need to find the derivative of our function. Easier than the first one. Don't you think? This derivative should be way easier. Okay, help me with the derivative. 3x to the second equal minus 2x minus 5. Now, we have to set it equal to